Welcome to the second to last video of our tutorial series on the air motor. Today we dive into the animation area of Fusion and learn two ways to create an animation. First, we will show you how to create an exploded view, where the individual components of the motor are pulled apart to clearly demonstrate the assembly. Then you will learn how to create an assembly video in which the components are brought together step by step. Let's start right away. Fusion offers various workspaces that we can switch between with a click on the button in the top left. So far, we have created our pneumatic motor in the design area. Additionally, there is the generative design area, which allows the design of components considering geometry, manufacturability, and performance. Additionally, different design solutions can be generated automatically there. In the rendering area, realistic representations of our designs can be created, while the simulation offers further possibilities to verify our components, for example, to test the load capacity of a component. The manufacturing section contains numerous tools that help plan and optimize the production process. In the drawing area, both individual part drawings and assembly drawings can be created automatically or manually, which we will elaborate on in the next video. To create our assembly video, we now switch to the animation area. You will see that the environment has changed and new tools are available. Additionally, a timeline, the animation schedule, appears at the bottom in the image area. You can move this window as you like by clicking and dragging the upper edge of the window with your mouse. You can also adjust the size to improve clarity. In the timeline, we work by default in a storyboard. All steps of our animation are shown in this. Right-click on your first script and rename it to Exploded View so you can find it more easily later. In the upper function area, we find a camera icon with a red dot under the View command. This means that our views are being recorded during the animation. Move the time slider to 3 seconds to try this out. Then rotate the pneumatic motor about 180 degrees and zoom in on the flywheel with the middle mouse button. A new camera movement appears in the storyboard timeline, which we can play with the play button. Such camera movements are ideal to focus on specific components. You can adjust them on the timeline by dragging them longer or shorter. To delete the camera movement, right-click on it and select Delete. If you click the View command again, the camera icon changes to a yellow pause sign. This indicates that no further camera movements are being recorded. Now we start creating our first explosion animation. First, we show the option of an automatic explosion animation. To do this, mark all parts and select under Transform the command Automatic Exploded View all levels. With the slider, you can set how far the components are pulled apart. Adjust the spacing so that all parts are clearly visible. On the timeline, all the individual movements of the parts are now visible. By moving the time slider, you can adjust the speed of the animation and determine how long it plays. Congratulations! You have successfully created your first exploded view animation. When playing back, it becomes noticeable that some components are not moving in the intended disassembly direction. We can solve this problem in two ways. The first option is to adjust the individual movements. To do this, we right-click on the animation track of the corresponding component and select the Edit Action option. In this menu, the movements on all axes can be specifically adjusted to ensure correct representation. However, we choose the second method to create the movements manually. For this, we select all the animation tracks created so far and delete them. Then we select the Manual Explosion Representation option in the Transform menu. We move the animation time again with the time slider to about 10 seconds. Now, we have the option to click on each component individually and select the correct disassembly path. Repeat this process for all other components. To correctly choose the direction for some components, it can be helpful to hide the engine block. Afterward, we can adjust the distance of the components using the slider. When all the parts are pulled apart in the correct direction, we watch the animation. It is noticeable that not all components are moved at the correct distance and the right spacing. To adjust this more nicely, we create a new storyboard. Since we want to start with an empty animation, we leave the component cleaning option activated. We rename our new script to Exploded View 2. This time, we create an animation individually and successively for each component. We start with the countersunk screws of the cylinder head plate. Hold down the Shift key and select all 4 countersunk screws. Then, in the menu, we open the option to transform components under Transform. Now we can move the countersunk screws as far away from the engine block as desired. In the animation timeline, we highlight the created movements and adjust their duration. We repeat this process for the cylinder head plate. To represent a realistic movement, we adjust the speed of the animation and shift it slightly backward in the timeline, so that the movement of the cylinder head plate begins only after the countersunk screws. We repeat this process for all other components until the entire animation meets our expectations. Once all components are moved, we look at our animation. If individual components do not move at the right time, that is not a problem. You can adjust the timing of a component in the animation area at any time. When you are satisfied with your animation, we can still adjust the recording view. To do this, activate the position recording by clicking on the camera symbol. Move the time slider to 0 seconds and let your animation play through. Lastly, center the view again, so that all components are fully visible on the screen. In the animation area, we can now see that the view has been captured. Now we extend the camera movement to the beginning and start the animation again. Very nice! You have created a professional and clear exploded view. You can save this as a video at any time by using the Publish button. Finally, we want to create an assembly video. For this, we start with a new script. To do this, we click on New Storyboard and select the option Start from the end of the previous. This way, the new animation starts exactly where the previous animation ended. To keep track later, we rename this script to Montage Video. Make sure that our camera view is not recorded initially. Then, move the timeline slider to 1 second and select the pleuel in the browser. With the command Restore Home, we bring the pleuel back into the piston. This creates an animation that moves the pleuel to its position in 1 second. Then we move the time slider to 2 seconds, select the pen, and bring it back to its position using the same command. We play the animation once and see that the pleuel and the pen are properly assembled. We repeat this process for the remaining components until our pneumatic motor is correctly reassembled. Once you're satisfied, you can play your edited video. If you don't like some steps yet, you can adjust them in the animation area. When everything fits, we'll activate the camera view again and start our animation again. Finally, we center our view again and extend the camera movement to the beginning. Perfect! Your montage video is now ready too. You can also export this as a video at any time. Congratulations, you did it! You have mastered the animation area and now know how to create exploded views and assembly videos. Don't forget to save your air motor at the end. Watch our last video now to learn everything important about creating technical drawings. Good luck!